Hi, you guys. How is everyone feeling about a test? um, yeah, email me if you have any questions or anything. I would love to clear up any confusion you might have going into this, but I think this worksheet will do a lot of that too. So, one of the things I want you to think about when you're taking the test, as of right now, anyway, there's two different parts. There's an online quiz component that you would take through Canvas, and there's like a written section. It says FRQ, free response questions. So when you're taking this test, make sure on the portion that you're doing on Canvas that you still have this in front of you. Not this necessarily, sorry, not this. The test FRQ part in front of you. You can't have notes in front of you when you take this. That I did not mean that. But you should have all these formulas, which will be on the written portion of the test. So a couple things I want to point out. If you look at these formulas, if we put a little break right here, notice these are all arithmetic formulas. This is recursive. This is explicit. Okay. Then this next little batch of formulas are geometric. Remember, whenever they have an R in them, that's geometric. This one is recursive. This one is explicit. And then these are the sum formulas. So this is for the arithmetic sequence. The finite, like if it has an end to it. Sorry, that E doesn't want to write. And this is the geometric for a finite series. That's terrible. Really sorry, guys. It's way harder to write when I don't have my podium, I've noticed, because nothing in my house is slanted like my podium. And then this is geometric for an infinite series. So keep that in mind as you take the test, where all of those fall. That's super helpful to know what those are. Okay, here we go. Question number 1. It says, given the sequence, find a recursive formula and explicit formula. Notice what's happening in the sequence first. So if you have 2 and then 6 and then 10, you're adding 4 each time. Okay, so that's one of the components that we need to get. They ask for a recursive formula. And if you notice right up here, recursive formula always has 2 parts to it. It has the a sub 1, which is your first term. And in this, the first term is 2. And then the second part of it, you're going to have a sub n, just like you see up here. And remember, this part never changes. So a sub n equals a sub n minus 1. And then it's plus your common difference. Well, our common difference is 4. So that would be our recursive formula here. The explicit formula that we're going to write is this one. So this is going to be a sub n equals a sub 1, that's our first term, plus, this one, the common difference is here. I don't know, on the test it might be back here. There's no difference. So common difference in front, common difference at the back, it does not matter. Yeah. So what we're going to do is 2 plus, well, I'll just write it this way for now since that's where the common difference is. 4 is the common difference, and then n minus 1. So if we simplify this, we're going to distribute, and we get a sub n equals 2 plus 4n minus 4. And then simplify that, a a sub n equals 2 minus 4 is a negative 2, and we have the 4n, so 4n minus 2, and that will be your explicit formula. So then if we're looking for the 15th term, remember when you're looking for something that's a little ways off, you never want to use the recursive. That'll just take you a long time. So instead, we're going to use the explicit. We're going to plug the 15 in here and here. So a sub 15 is 4 times 15 minus 2. So you get, plug that in, 60 minus 2 is 58. Okay. Then if we want to do the sum, remember this we said was an arithmetic sequence because we're adding 4 each time. So if you look up here, the sum with an arithmetic sequence is this one. So that's the formula you're going to be using. Guys, one of the biggest things you can do for this test is make sure you know which formula is used for what. Because the formulas are going to be there for you. You need to know when to use them. So just make sure you spend some time on that. So this one, the sum, we first have to figure out how many terms, right? If we're going to do this formula, S sub n equals n over 2 times a sub 1 plus a sub n, we need to know what n is. We need to know how many terms. Well, remember what we said before, that a sub n, like if we look here, right, or we look here, a sub n is your last term. So if you look up here, our last term is 118. So I'm going to plug in 118 equals 4n minus 2 and solve that. So add 2 and 120 equals 4n and divide by 4. So n is 30. That means there are 30 terms in this sequence. So then you come down here, and that number, that 30, is going to go right here. So it's going to be 30 divided by 2. Okay, our sum is 30 divided by 2 times a sub 1 plus a sub n. First term, last term. So 2 plus 118. And you would plug that into your calculator, and you should get that the sum of those 30 terms is 1,800. Okay. Number 2. Given the sequence up here, find recursive, explicit, a sub 8, and s sub 8. Let's see what this one is doing. So to get from 2 to 6 and from 6 to 18 and 18 to 54, we're multiplying by 3 every time. So this is a geometric. Okay. So the recursive formula for geometric is right up here. So we're going to say a sub 1 is 2 and a sub n equals a sub n minus 1 times the common ratio, which is 3. So that's your recursive formula. Your explicit formula, this one here, is going to be a sub n equals, you need your a sub 1, right? So your first term, which is 2, times your r, which is your common ratio, that's the 3, that's what you're multiplying by, to the n minus 1 power. So that would be your explicit formula. So if we want the 8th term, I would plug in an 8 right here. So a sub 8, it doesn't look like an 8, equals 2 times 3 to the 8 minus 1. So really you're going to plug in 2 times 3 to the 7th power. That is not 6 to the 7th power. That is 3 to the 7th power times 2. Make sure you're not putting parentheses around the whole thing, okay? But if you just plug that in exactly how you see it, you would get that a sub 8, your 8th term is 4,000 374. Okay, then if we're doing the sum of those 8 terms, again, we said this is a geometric sequence. So if you look at your formulas, the sum for a geometric sequence, this is finite, right? Because it has an end. Did it tell us it has an end? Oh, never mind. It's finite because we're finding the sum of 8 terms. So we are going to do, excuse me, the sum of 8 terms is going to be our a sub 1, that's 2, times 1 minus our common ratio, 3. I missed my exponent. To the n power, 8, over 1 minus the common ratio. Okay, so I just plugged it into this formula. Okay. Sorry, I didn't plug the ratio in. I just looked at the formula. That'll be a 3. And then you want to make sure that you put parentheses around that. If you forget these parentheses and you plug it all in, it doesn't work out. So make sure you plug this into your calculator, 2 parentheses 1 minus 3 to the 8th, get out of that exponent mode, finish off your parentheses right here, divided by parentheses 1 minus 3. And when you do that, plug this in right now. You want to double check this because sometimes if you plug these in slightly differently, you get a very different answer. 6,560 is what you should be getting. All right, number 3. Notice here's all your formulas again, so you don't have to keep jumping up to the top if you want to start looking down at the bottom. This one says write the first 4 terms of the arithmetic sequence where a sub 1 is -5 and your common difference is 7. Guys, you don't even need a formula for this. If you have your first term already is -5, and then your common difference is 7, that means you're adding 7. So if we add 7, we get 2. If we add 7, we get 9. If we add 7, we get 16. Okay? Done. Arithmetic adding. Number 4, write the first 4 terms of the geometric. Geometric, you're multiplying. Plus over there. So a sub 1 is 20. And then your common ratio is -2. So times -2 would be -40. Times -2 again would be a positive 80. And times -2 again would be a -160. And again, you're done. Please don't think you need to come up with a formula there or use a formula there. You can just think through what that would be. All right, arithmetic mean. Remember with arithmetic mean, you have to take the numbers you're given, add them together, and divide by 2. You're finding an average, right? So 31 plus 55, and then divide by 2. Make sure you hit enter or put parentheses around that addition. So this should be, 86 divided by 2, which is 43. Okay. Number 5, geometric mean. This one you're not adding anymore. Now you're multiplying. Remember, geometric, you're always multiplying. So 30 times 120, and then you take the square root of it. So it's always the product of the 2 numbers, and then square root it. That comes out to 3,600 square rooted, which is 16. Okay. All right, this one, right? The first 4 terms of the sequence. This is one where you can really just set it up in your calculator to do the work for you. So if you plug into your calculator, 1 is my first term, right? Plus 2 with the parentheses, and then 1 minus 3 with the parentheses. When you plug that in, you get -6, okay? Now on your calculator, hit second entry and just turn this number into a 2 and this number into a 2 and then hit enter again, and you should get -4. Okay, do the same thing for your third term. You're going to plug a 3 in here, second entry, right? We'll get you that this whole thing back. Just change this to a 3, change this to a 3. When you plug that in, you get 0. and then a sub 4, plug it in, make a 4 here and a 4 here, and that one you get a 6. So your first four terms would be -6, -4, 0, and 6. Okay. For this one, find the first four terms. Again, you already have your first term in a recursive formula. So we know our first one's going to be -4. So if I want the second term, I'm going to do 3, and then remember what a sub n minus 1 is. That's the term right before it. So for the second term, I want a sub 1. 2 minus 1 is 1, right? So I want to plug in my last term right here, -4. My previous term is a better way to say that, I guess. So a sub 2, that comes out to -10. Okay, so here's your 1, here's your 2. A sub 3 then is 3 times, now we're going to plug this one in, -10 plus 2, and you get a -28. And then a sub 4, our fourth term, is 3 times a -28, right? This one just gets dropped in, plus 2, and you get a -82. So -4, -10, -28, -82 is your sequence. Okay, backside. Here's all your formulas again. This one says find the sum of the series. So first of all, you want to take a look at it and see what's going on here. 4 to 7 to 10 to 13. We're adding 3 each time. And if we're adding, that means it's arithmetic. Okay, so it's an arithmetic series that we're looking for the sum of an arithmetic series. If you want to relabel all of these, again, at the top, go for it. It would be all the same labels from the ones on front. They're exactly the same. So we know we're using this formula. Okay, S sub n equals n over 2 times a sub 1 plus a sub n. We know most of this already, but not all of it. We know that a sub 1 is 4. Why are my 4s so horrible on here? I'm so sorry. 4. And then our a sub n, that's our last term, we know is 64. So really all we're having to figure out is n, how many terms this has. The way we do that, if you recall, is we use the explicit formula. So remember the explicit formula for an arithmetic series up here. We're going to plug in what we know about that. So we know that 64 is our a sub n. We know our first term is 4. We know our common difference is 3. Oh, now it's at the back, sorry. Times n minus 1. This is the number of terms, so that's what we need to solve for. So we're going to distribute here. 64 equals 4 plus 3n minus 3. Sorry, my kiddos just woke up. What time is it for you guys? It's 6:45 for me. Okay, so we have 64 equals 3n plus 1. So take away 1, 63 equals 3n, and then divide by 3. So n is 21. Okay, so we're going to take that, and we're going to plug it in right here. And I'm just going to erase from this. That's not erasing, that's highlighting. Okay, so if I plug this in, there we go. Sorry, glitchy. This is what you're going to plug in, and you can just plug that into your calculator, how you see it with the parentheses, and it should do the work for you. So your sum here is 714. Okay. Number 9. this one says if a sub 1 is 5, d is 3, and n is 12, find the sum. So now this time we don't have the last term, but we again can look at this. If there's a d, it's arithmetic, right? This is an arithmetic series. So we have first term, we have common difference, we have number of terms. What we're going to do is plug this into the arithmetic formula before we plug it into the sum formula. So we have a sub n equals our first term plus n minus 1 times the common difference. Okay, so if we, oh shoot, I forgot to plug in n, sorry. Our n, they told us is 12. So plug that in here. And then you can plug that in, again, exactly how you see it. 5 plus parentheses, 12 minus 1, parentheses, parentheses 3. That gives us an a sub n of 38. Okay, so now we have everything we need for our sum formula, which is not that one. Sorry, I can't see the full thing on my screen. This one. So it's going to be the sum is the number of terms divided by 2 times our first term plus our last term, which we just figured out was 38. And then we will plug that in. Apparently I didn't calculate it yet. Give me a sec. So that comes out to 258. Okay, so that would be the sum of that guy. Oh. I wonder, did this happen on yours? Oh my goodness, what happened?
What did?
Okay. No, it's fine, bud. Huh. I wonder if this is what yours looks like. Really sorry if it does. I'll write the new stuff in. I hope it doesn't do that on the test. Okay, so what this should be your sigma, not an A. So it should look like 40 on top and equals 1 on bottom, and then 5n minus 1. Sorry about that. Okay, so number of terms. If we're starting at 1 and we're going to 40, that is 40 terms. Keep in mind, if you just subtract these, right, that gives you 40 minus 1 is 39, but you have to always add 1 to that. So if you're just going to subtract those to find the number of terms, make sure you always add 1 to it. And then when they ask you for the first term, what you're doing is you're plugging this number in right here. So 5 times 1 is 5, minus 1 is 4. And then your last term, you're plugging this number in right here every time. So if we do that, 5 times 40 minus 1 is 199. Okay, so you have your number of terms, your first term, your last term, and now you can plug it into the sum. Remember, this is summation notation. So we're going to plug that into our sum formula for an arithmetic. Remember that. So if you look at your arithmetic formula, that is the one that does the number of terms over 2 times the first term plus the last term. And if you plug that in, you get 4,060. Okay. Number 11 here, write the first 3 terms of the infinite geometric series if r is 0.2 and a of 1 is 20. So you're going to take that 20 with a common ratio of 0.2. You're just going to go times 0.2, and you get a 4 right here. Then you're going to multiply by 0.2 again, and you get 0.8 for that one. Okay, so the sum, note this is the sum of an infinite, man. So this is the infinite one. On the front, it was the wrong symbol too. Apparently when you make it a PDF, it does not like you switching things. So the sum here to infinity, this is one of those that's getting smaller, 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 smaller. We actually have a number that we're going to get. So if we plug into that formula, this formula, it's going to be our first term divided by 1 minus our rate. When you do this one, make sure you put parentheses around this because you want to divide by that whole thing, not divide by 1 and then subtract 0.2. So when you plug this in, you should get 25. Okay. Number 7. Oh, this is hideous, you guys. I'm so sorry. Let's say this is 8. This is n equals 6. And this is negative 5 times 3 to the n power for your formula there. Okay, so this one just says find the sum. This is not to infinity, so you are using geometric here, this formula. So if you look at this, we need to know what our first term is. So a sub 1. Our first term is when we plug this number in. So if we do negative 5 times 3 to the 6th power, when you plug that in, our first term is negative 3,645. Okay. Our common ratio, what we're changing by, is always this number. Remember, think of it kind of like exponential growth, exponential decay. That's our ratio, would be 3. And then the number of terms, okay, our n, our number of terms. If we have 6 as our first and 8 as our last, 6, 7, and 8 would be your number of terms, so that's 3 terms. Or you can think 8 minus 6 is 2, and you always have to add 1 to that. Okay, so if this is my setup, I'm going to plug it into that formula. A sub 1 times 1 minus the rate to the n power over 1 minus the rate. And make sure you keep all those parentheses exactly how you see it. And when you do that, you get a sum of negative 47,385. Okay. You do have another option here. The other option is you could find the sum, thinking of it as you have a 6th term, a 7th term, and an 8th term. So you could just do negative 5 times 3 to the 6th plus, so this, plus negative 5 times 3 to the 7th, plus negative 5 times 3 to the 8th, because it's a sum, right? So you could just plug it into your calculator like this as well. Part B, again, sorry about the ugly picture. I have to go back and mess with that. So n equals 7, this is 10, and this is n squared plus 2. Okay, so for this one, I would just do it the way I just showed you. You're taking 7 squared plus 2 plus 8 squared plus 2 plus 9 squared plus 2 plus 10 squared plus 2, right? So we start at 7, we work our way all the way up, 8, 9, 10. Take the sum of all of that, and if you plug that into your calculator, you get 302. Okay, number 13. Find the sum of the first 300 numbers. So if you think about this, you're doing a sum. This is arithmetic. We're adding each time. So n, your number of numbers, is 300. There are 300 numbers that we're adding. Your first term, you would start at the number 1, and your last term is 300. So what we're going to do is we're going to plug that into the sum formula. So 300 over 2, not equals, times your first term plus your last term. Oh man, those kids are having fun outside. So the sum, when you plug this in, should be 45,150. Okay. Number 14, write the arithmetic series using summation notation for 15 terms, given the first 3. Arithmetic series, okay, is what we're writing here. So, but it also says using summation notation or sigma notation, okay? So if you look here, 7 to 12, 12 to 17, we're adding 5 each time. And then if you think about what this arithmetic formula would be, we have our a sub n equals the first term, that's 7, plus our n minus 1 times the common difference, which is the 5. Okay, if we simplify this, we get 7 plus 5n minus 5. So it's going to be 5n plus 2 for our explicit formula. Okay, so we have this. We want sigma notation or summation notation. So we have our first term, n equals 1, and we are going to 15 terms. And then we write in our explicit formula, 5n plus 2, and this will be your answer. Okay, so summation notation, but you do need to come up with the explicit formula first, okay, because that's what we're going to put here. All right, number 15. A 60-row theater has one aisle. Those sections have 20 chairs in the first row, 2 more in each succeeding row. Find the total seating capacity of the theater. So if you think of, you have this aisle, okay, and then you have all these seats over here. It says there are 20 chairs this way and 20 chairs this way, okay. So in your first row, you have 40 chairs, okay. Then the next row, you're adding 2. So there would be 22 here and 22 here. So you're actually adding 4 to the sequence, to the series, since we're adding them. So it would look like this as we go, to eventually get to some number, which we're trying to find what that number is, so that we can finish solving the problem. We do know that there are 60 rows. So if this is our first row, then this is our 60th row to end the problem. Okay, so we need to make an explicit formula for this. So let's do that. We're going to say a sub n equals, we're going to take our first term, which is 40, plus n minus 1 times the common difference. And our common difference, what we're changing by each time, is 4. Okay, so if we simplify this, 40 plus 4n minus 4, so we get 4n plus 36, okay? We're trying to figure out for 60, okay? So we would say our a sub n, which is this term up here, right, is going to be 4 times 60 plus 36. So our a sub n, our last term here, is 276. Okay, that's this number, 276. We're trying to figure out what is the sum of all of the seats. So the last row has 270 seats, but the sum of them all, you need to use the sum formula. This is an arithmetic series, right? We're adding each time. So our sum formula for an arithmetic is going to be n, which is 60, over 2 times the first term plus the last term. And when you plug that in, you get a sum of 9,480 seats. Okay. All right, last one. Almost there. This says the first term of a geometric series is 8. If there are 20 terms and r is 2, what is the sum? So we can say 8, and then our next term, if we're multiplying by 2, would be 16. And then our next term would be 32, and our next term would be 64. So you could do that 20 times. It's a pain in the butt, but you could. And it gets to be a really big number. Yeah, I wouldn't do that. Don't do that. But what I would do is we're trying to find the sum of a geometric series. Okay, so you're using the sum formula, this guy up here, okay, of a geometric series. So it's going to be a sum for 20 is your first term times 1 minus that common ratio, which is 2, to the n, which is 20, over, and then don't forget these parentheses, 1 minus 2, and you literally plug that into your calculator, and you get, S sub 20 is 8,388,600. Okay, that's it. Good luck. Let me know if you have any questions.